Students, I'd like to talk a little bit about the autonomic nervous system. And in the autonomic nervous system, similar to automatic pilot for pilots, we have the autonomic nervous system in the body. It functions without us having to think. Okay? Good thing, because our body is so complex that we cannot handle it if we had to make all the decision makes in a second, if you will. First of all, autonomic nervous system, also called the visceral nervous system. And I like this definition, if you will, or this thought. The dynamic nature of life is too complicated to have a conscious, voluntary response. It requires a genetic, predetermined system to assess and respond to the changing environment. Homeostasis. Okay? In order for us to keep ourselves alive and healthy in a constantly changing internal and external environment, we have to have a system that is super intelligent, programmed to keep us alive. That's the autonomic nervous system. Divided into two parts. One we have is a sympathetic nervous system. That's when we're in emergency mode, okay? And then we have the parasympathetic when we're not in emergency mode. Some consider this one rest and digest. Let me go on and just go on to some other topics here. I'm going to go a little bit fast to see if we can follow. Sympathetic nervous system, you might consider has 4 different highways, 4 areas of specificity. Beta 1, beta 2, alpha 1, alpha 2. Beta 1, heart, pretty much. Beta 2, lungs, 2 lungs, there you go. Alpha 1, heart is vasoconstriction. Alright, deals with the blood pressure. And this is going to be, alpha 2 is a little unusual. It works a little different. When it works, actually, if you want to know, our blood pressure goes down. It's an interesting fact. I consider this rabbit turtle. Okay. With that in mind, adrenergic is based on the neurotransmitters epinephrine or norepinephrine, adrenaline or noradrenaline. These are the same thing, just different names, and collectively they're called catecholamines. Catecholamines. Yeah. So whatever textbook you're reading, hey, they may use this term, whatever. Be ready for any. Why would the sympathetic nervous system kick in? I'll tell you why. You're in a state of emergency. Okay, there's a threat. With that in mind, what can we expect the body to do? This is very predictable. Alright, so, eyes become dilated. Pupils are dilated. The mouth, dry, sticky saliva. Lungs. Now, here we got an improvement. Bronchodilation, maximum airflow. Alright, the lungs, if you will, open up, get a lot of oxygen in there. Moving on. The heart, beta 1 territory. Fancy terms here, inotropic, chronotropic, dromotropic. Inotropic basically is this, increased contractility. The heart gives a stronger muscle contraction. Chronotropic, faster. The heart will beat faster. And dromotropic basically deals with the electrical velocity on the EKG. Gives it a stronger one, if you will. Either or, what this is going to boil down to is increased cardiac output, more perfusion, the blood getting around to where it needs to go when you're in a state of emergency. Alright, pulse rate, blood pressure up. GI, relaxation. You don't need to digest the food at that point when you're in a state of emergency. Alright, priority system. Bladder, detrusors, which help us void, they contract to help us expel our urine. Well, guess what? No, pretty much no activity there. And the uterus, when the sympathetic nervous system kicks in, the uterine contractions are diminished. And it's used as a tocolytic to stop urinary contractions. Alright, liver, glycogenolysis, the release of stored glycogen. Glycogen in the liver stores glucose, and a little bit of epinephrine starts to break down, makes available sugar. Sugar availability, and vasculature vasoconstriction, sympathetic nervous system. Now, take a look here. Here you got it. Glucose availability, a lot of oxygen, and a fast heart, and a lot of cardiac output. You're making plenty blood available to the skeletal muscles, and the quality of the blood is going to have glucose in it, it's going to have oxygen. So once that stuff makes its way into the mitochondria, you're going to make a lot of ATP, and you're going to have a lot of energy available to perhaps save your life. There you go. Now, as far as medications with the sympathetic nervous system, you have some that stimulate, so they copy sympathomimetics, or you have agonists. Agonist means my friend. Or you have something to go against. Antagonists or sympatholytics. Lytics would mean like breaking down, but in this case it means opposing the work of the sympathetic nervous system. Moving on, just the opposite. We have the parasympathetic. Some people call it rest and digest. Here you go. It's called cholinergic based on the neurotransmitter acetylcholine. What happens to the eyes? Constriction, or pupillary constriction. The pupils. A lot of saliva, so you can digest your food. Swallow the saliva. Saliva has enzymes and stuff, helps you with digestion. Lungs, not a good friend for breathing, if you will. Actually, bronchoconstriction, narrowing of the airways. Heart, the heart rate slows down. Just like the vagus nerve when it's stimulated, massage, don't do that. That's carotid massage to stimulate the vagus nerve, slow your heart rate, could be dangerous. Or Valsalva maneuver, that engages the vagus nerve, which helps kickstart the parasympathetic nervous system. Okay. GI, increased motility, that basically means peristalsis speeds up. Okay. Helps with digestion. Acid secretion goes up. Parasympathetic, need acid, digest your food. Hydrochloric acid, we call. And defecation, the increased motility helps you with defecation. Bladder kicks in the detrusor muscles. Good friend to detrust your muscles, get that good urine output. Okay? Medication, parasympathetic meds, what can they be? Cholinergics that help this get going, or you can have what? Anticholinergics. Probably the classic one is aspirin. Okay? Let's go up to an acronym that's very popular called SLUDGE. And you can associate that with the parasympathetic nervous system when it kicks in. Perhaps over kicks in. Increased salivation, yes. L, lacrimation, tears. Urinary incontinence, maybe too much detrusor activity. Diarrhea, maybe too much motility. There you go. Gastrointestinal cramps, too much peristalsis, ouch. And then emesis, we call that sludge. A whole bunch of fluid. All right, there you have it, the autonomic nervous system. And again, I have to say, autonomic nervous system, also called visceral. Dynamic nature of life is too complicated to have a conscious, voluntary response. It requires a genetic, predetermined system to assess and respond to the changing environment. Very back homeostasis. I'll quickly take this up, listeners, and you can probably take a look at it a little bit closer. A little bit of glare here, but if that helps out, there you have it. And here we have, again, sympathetic nervous system, catecholamines, and so on, and meds here, and parasympathetic. One of the reasons I consider this a priority is that when we work with medications, the medications work in concert, either opposing the work of the autonomic nervous system or helping it work even a little bit better. Thank you very much. Thank you very much for listening.